हॅलो स्टुडंट्स. म्हाज्या मोगाळ भुरग्यांनो म्हाका पळोवन खूब उमेद जाता की म्हाजे गोंयचे भुरगे म्हाजो यूट्यूब चॅनल पळोवन कॅमेस्ट्री शिकता. आनी खुबश्या भुरग्यांचो रिक्वेस्ट आसलो की हांव जी प्रिवियस इयर क्वेश्चन सॉल्व करता गोवा बोर्डाचे ते चालूच दवरचे. आनी आज हांव न्यू व्हिडिओ घेवन येयला आल्डिहायड्स कीटोन कार्बॉक्सिलिक एसीड. हो मातसो टॉपीक मातसो टफ कम्पेर्ड टू ऑल द ऑर्गेनीक चॅप्टर्स ऑफ द कॅमेस्ट्री. आनी मातसो लेंथी टॉपीक, त्या खातीर व्हिडिओ मातसो व्हडलो जाला. ऑलमोस्ट 2 वरांचो व्हिडिओ जाला. हो व्हिडिओ जेंच्यांनी खूब प्रॅक्टीस करुना, रिएक्शन्स जेंच्यांनी प्रॅक्टीस करुना, or those students who are learning it for, like, some topics are they are learning for the first time also, for them also this video will help lot. हांव मागता की तुमी हो व्हिडिओ कंप्लीट पळया आनी तुमचें प्रेपरेशन परफेक्ट जातलें अबावट द आल्डिहायड्स कीटोन कार्बोक्सिलिक एसीड. आनी प्लीज लायक, शेअर एंड सबस्क्राईब. थँक्यू. The structures X and Y form in the following reaction is asked. सो ह्या रिएक्शनान स्ट्रक्चर विचारला, हेजो एक्साचो कितें स्ट्रक्चर आसतलो आनी व्हाय कितें आसतलो. सी, फर्स्ट ऑफ ऑल वी हॅव टू आयडेंटिफाय द रिएक्शन. लायक दीस रिएक्शन, देर इज अ बेन्झीन, देर इज अ बेन्झीन घेतला. सो बेन्झीन आनी कोण, कार्बोनिल प्लस HCl in the presence of CuCl. So what is the name of this reaction? सो हेका म्हणटा गेटरमॅन कोच रिएक्शन. पयली एकदां हांवें तें सॉल्व केला प्रिवियस क्वेश्चन. गेटरमॅन कोच रिएक्शनान तुका कितें मेळटा, बेन्झाल्डिहायड मेळटा. रायट, दीस इज बेन्झीन आनी हे बेन्झाल्डिहायड. हो बेन्झाल्डिहायड मिन्स वॉट आमचो स्ट्रक्चर एक्स. वॉट इज द नेम ऑफ दीस रिएक्शन? हांगच्यान हांगा कन्वर्ट जावंक ताका आमी म्हणटा गेटरमॅन कोच रिएक्शन. गेटरमॅन कोच रिएक्शन, कोच रिएक्शन. आणि फर्दर what is asked? It is zinc mercury HCl, zinc mercury and HCl. म्हणजे this reaction is a Clemenson's reduction. This is a Clemenson's reduction. Clemenson's reduction कशें जाता? हो सेम हांव कार्बोनिल कंपाउंड आसा हांगा, हो सेम कार्बोनिल कंपाउंड आसा तो हांव कसो बरयता, 1 minute. सेम कार्बोनिल कंपाउंड आसा तो कसो बरयता, C डबल बॉन्ड OH. म्हणजे जेन्ना क्लेमेन्सन जाता तेन्ना आमी हांगच्यान कितें करता, हो ऑक्सिजन काडटा. रायट, वो ऑक्सिजन काडटा आनी हांगा कितें घालता, 2 हायड्रोजन घालता. करेक्ट, दॅट इज वॉट आय एम गोइंग टू डू. हे दोन्ही ऑक्सिजन काडले आनी हांगा 2 हायड्रोजन घातले, और हांव ते अशें बरयता. 2 हायड्रोजन घातले आनी ऑलरेडी एक हायड्रोजन आसलो तेजेर. ओके, सो वॉट इज द मिनींग ऑफ दिस? दिस इज द स्ट्रक्चर आय कॅन रायट दिस वे, CH3. CH3 म्हटल्यार कोण, टोल्युइन. आनी वच तर म्हाजो वाय. रायट, सो एक्स इज वॉट, बेन्झाल्डिहायड, वाय इज टोल्युइन. म्हणजे तुजो आन्सर कितें जाता, कमेंट करा आनी सांगा वो आन्सर. रायट, दिस इज वॉट इज आस्क. So over here, what is asked is toluene is oxidized using KMnO4 in a basic medium, KOH, followed by hydrolysis. So how do we go about this? See, KMnO4 in an acidic medium, we know that directly we get a benzoic acid. So toluene, so over here, this is your toluene. Or methyl benzene is same as toluene. And you are doing the oxidation. See, understand, KMnO4 is a very strong oxidizing agent in the presence of KOH. Basically, it will oxidize it to a benzoic acid, which will give you a salt, because the medium over here used is a basic. Medium over here used is basic, KOH. So over here, what you are going to get is a potassium salt of benzoic acid. This is called as a potassium salt of benzoic acid. Benzoic acid. And further, if you do the hydrolysis of this, what do you get? You get a benzoic acid. COOH. This is the reaction which was expected from you to write. This is benzoic acid. If it is acidic medium, directly at this stage you are writing a benzoic acid if it is acidic medium. If it is base, then potassium salt or whatever salt base is, you like sodium hydroxide and sodium salt of benzoic acid. That way it will go. Right. Next is acetyl chloride reacts with a, this is our A. Next is acetyl chloride reacts with a hydrogen in the presence of palladium and the barium sulfate. So this is a name reaction called as a Rosenmund reaction. Rosenmund reaction. Rosenmund reaction. Acetyl chloride. Acetyl chloride is what? Acetyl group is this CH3COO, and here it is a chloride. And if you do the hydrogenation in the presence of palladium plus barium sulfate, this is a reduction, but partial reduction. What you get is a aldehyde, C double bond OH, and this is ethanol. This is what you are getting over here. Answer the following question. Arrange the following compounds in the order of their increasing reactivity towards cyanide. हो क्वेश्चन विचारला न्ही हांगा. हो कसो विचारला? हो क्वेश्चन इज सिमिलर लायक where the reactivity with the nucleophile was asked. Similar type of question. Because hanga CN minus nucleophile म्हणून exactly. Nucleophile म्हटल्यार electron rich. So let's illustrate this. A question on I'll write the structures. CH3 C double bond OH. Okay. दुसरो असा formaldehyde. आणि तिसरो असा कीटोन. आता हांगाच हांवें पयलीं सांगलेलें की न्यूक्लियोफिलिक रिएक्टिविटी or nucleophilic reactivity is more on aldehyde compared to that of the ketone because of the magnitude of the positive charge and less hindrance, steric hindrance. Nucleophile can attack the carbonyl carbon very easily. हांगाय partial positive charge असा, हांगाय partial positive charge असा, हांगाय positive charge असा. पण in ketone the magnitude of the partial positive charge is very very less, or comparatively less we can say, because of the electron donating nature of these two groups, and there is a steric hindrance created by these two groups and it obstructs the incoming nucleophile, attack of the incoming nucleophile. So सगळ्यात चड magnitude आसा तो खंयसर on formaldehyde. I'll write this. This is formaldehyde. आणि हांगा कितें आसा इथेनॉल. दिस इज इथेनॉल और एसिटाल्डिहाइड सुद्दां म्हणटा हेका इथेनॉल. आणि दिस इज प्रोपेनोन और एसिटोन सुद्दां म्हणटा हेका प्रोपेनोन. नाउ न्यूक्लियोफाइल, it is reacting with the HCN. See, same question, nucleophilicity, okay, nucleophilic attack. So हांगा कितें जातलें, हो तुजो CH3, this is your CH3 and what is a carbonyl. So nucleophile CN minus is on the carbon, understand. This is a nucleophile, it will attack on this carbon and you will get the cyanohydrin. मतलब हो असो कन्वर्ट जाता CO minus H आणि CN, आणि जो H असलो पयलीचो तो येवन हांगा कंबायन जाता आणि दिस चेंजीस टू OH. एका इन जनरल म्हणटा सायनोहायड्रीन. सो होच अटॅक विचारता ते तो बेस्ट कितून जातलो. दे हॅव आस्क इनक्रीजिंग ऑर्डर. सो इनक्रीजिंग म्हटल्यार विकस्ट आसतलो किटोन, सो दॅट इज प्रोपेनोन. That is propanone. So your answer will be this. When you are writing, this is your answer. Propanone, then ethanol, and maximum in formaldehyde. This is the simple answer you have to write for the exam to get that 1 mark. Next is allow write the structures of the A and the B in the following reaction. So वो रिएक्शन वो क्वेश्चन आसा, दिस क्वेश्चन इज अबाउट द हायड्रेशन. ओके, हा बरें, द हायड्रेशन ऑफ द अल्काइन. How do I understand? By looking at the reagents. Okay, there is a water and H plus. So hydration of alkyne. आता हायड्रेशन म्हणजे कितें? लायक हायड्रेशन ऑफ द आल्कीन जाणा तुमी. हायड्रेशन ऑफ द आल्कीन केलें जाल्यार आमकां आल्कोहॉल मेळटा. सो हांगाय कशें जातलें की हायड्रेशन ऑफ आल्कायन म्हटल्यार हायड्रेशन म्हटल्यार एडिशन ऑफ वॉटर. एडिशन ऑफ वॉटर. आणि तसोच एक टर्म आहा डिहायड्रेशन म्हणून. डिहायड्रेशन म्हटल्यार रिमुवल ऑफ वॉटर. सो हायड्रेशन ऑफ द आल्कायन, ही तुजी आल्कायन दिले हांगा. ओके, हांगा कांयच प्रॉब्लम ना बिकॉज इट इज सिमेट्रीक आल्कायन. असिमेट्रीक आसता तेन्ना तुका मार्कोनिकोव्स रूल फॉलो करचो पडटा. म्हणजे ते म्हणटा नेगेटिव्ह पार्ट गो टू द कार्बन वीच हॅज लेस नंबर ऑफ हायड्रोजन, तशें सगळें लागता. सो हांगा कितें कर, तूं खंयचोरूय घाल. हांगा घाल OH आनी हांगा H घाल. दॅट इज यू आर एडिंग H2O. OH आनी H म्हटल्यार वॉटर. सो तशें जाता. तूं खंयचोरूय घाल, वन एंड सेम. सो हांगा आफ्टर एडिंग वॉटर इन द प्रेझन्स ऑफ एसीड एंड मर्क्युरी सल्फेट कितें मेळटलें? दिस इज द कार्बन एंड हांगा एक हायड्रोजन वयता, हांगा एक OH वयता. सो दिस इज कॉल्ड एज अ इनॉल, जनरल वे ऑफ रायटिंग. वॉट इज द मिनींग ऑफ इनॉल? यू आर गेटिंग अ इनॉल. इनॉल म्हटल्यार याद धरा की जेन्ना OH डबल बॉन्डेड कार्बनाक कनेक्ट आसतलो तेका म्हणटा इनॉल. वॉट इज इनॉल? OH ग्रुप present on double bonded carbon. Double bonded carbon तेकाच इनॉल म्हणटा. इन फॉर अल्कीन, ऑल फॉर हायड्रॉक्साइड और अल्कोहॉल ग्रुप. सो हे इनॉल आसता ते अनस्टेबल आसता. इट इज नॉट स्टेबल, इट इज अनस्टेबल. अनस्टेबल, इट इज अनस्टेबल. एंड एट दिस पॉइंट कितें कन्वर्ट जाता तितून? सो दिस इज युअर A. This is your, sorry, this is not A. A फुडें म्हटलं. तर हांगा आमी म्हणटा तेका किटो इनॉल टावटोमेरिझम. किटो इनॉल टावटोमेरिझम. म्हणजे हे इनॉल आसा ते एक तर आल्डिहायडान नाल्यार किटोनान कन्वर्ट जाता. इन दिस केस इट विल गेट कन्वर्टेड टू आल्डिहायड. म्हणजे हांगा कितें जातलें? हायड्रोजन हो डबल बॉन्डेड O जातलो. हो H अशें अज्यूम करा की तो हांगा येयलो. म्हणजे तुमकां प्रॉडक्ट कितें मेळ्ळो? लास्ट तुमकां प्रॉडक्ट मेळ्ळो तुमकां प्रॉडक्ट मेळ्ळो CH3 C डबल बॉन्ड OH. म्हटल्यार तुमकां मेळ्ळो इथनॉल एज A. यू आर गेटिंग इथनॉल एज A. आतां फुडें कितें बरयलां? O बरयलां हेंच्यांनी. O फॉर ऑक्सिडेशन. O फॉर ऑक्सिडेशन. आतां म्हाका सांगा भुरग्यांनो की ऑक्सिडेशन समज आल्डिहायडाचें तुमी करता जाल्यार तो आल्डिहायड विल गेट कन्वर्ट टू वॉट? पॉज दीस व्हिडिओ फॉर सम टायम, कमेंट एंड सी. ओके, कितें आसता सदांच आमी शिकतना आनी एक्टीव लर्निंग ऑर पार्टिसिपेशन इज व्हेरी इम्पॉर्टंट. जो पर्यंत तुमी पार्टिसिपेट करिना, टिचरा कडेन कम्युनिकेट करिना, ऑफकोर्स हांगा स्कोप ना तुमकां डायरेक्ट कम्युनिकेट करपाक, बट यू कॅन ऑलवेज कमेंट. म्हाकाय तशें इतकें बरें दिसता की अरे भुरगीं म्हाजी ऑनलायन युट्यूबर शिकता आनी कमेंट बीन करता. सो दॅट इज गूड. बट क्लासीन सुद्दां जेन्ना तुमी शिकता तेन्ना खूब लक्ष दिवन जेन्ना तुमी टिचरा कडेन इंटरेक्ट करता तेन्ना बरे तरेन अंडरस्टँड जाता. तुमी खंयसरूय शिकू, तुमी तुमच्या ट्युशन टिचरा कडेन शिकता, तुमी तुज्या स्कुलान क्लासीन शिकता, हें जेन्ना इंटरेक्शन जाता तुज्या टिचरी कडेन आनी तुमी इंटरेक्शन करता आनी विचारता हे अशें कितें स्मॉल स्मॉल डावट्स विचारता तेन्ना तुमचें शिकप परफेक्ट जाता. ओके, सो ऑलवेज हॅव दीस हॅबीट ऑफ आस्कींग डावट्स आनी ते टिचरी कडेन एक बरें रिलेशन दवरून विचारप डावट्स. दीस इज व्हेरी इम्पॉर्टंट. मागीर दुसरी एडवांटेज सी, तुमी समज विचारना डावट्स ना, ऑफकोर्स यू आर वॉचिंग दीस व्हिडिओ, बट ऑफलायन लर्निंग आसता आनी ताचो इम्पॅक्ट खूब आसता. यू शूड ऑलवेज रिस्पेक्ट दॅट. कित्याक जेन्ना तुमी क्लासीन वयता आनी जस्ट टिचरीचें आयकून येता, जर कितें सांगता तें जस्ट आमी आयकता आनी येता, आनी आमकां सपोज समजना जाल्यार आमी विचारना, कित्याक आमकां एक भंय दिसता टिचर कितें म्हणटली जावं अशें कितें आमचे भितर एक भंय आसता. सो तो भंय काडून आमी उलयली न्ही टिचरी कडेन जाल्यार एक आमकां कॉन्फिडन्स डेवलप जाता. टिचर आमकां बरे तरेन गायड करूंक शकता. सतत याद दर हय. नाल्यार कितें जाता, तूं एक क्लासीन गेलो आनी एक व्हिडिओ पळोवन येयल्ल्या भशेन वेर यू आर नॉट इंटरॅक्टींग, तशें जाता गजाली. सो ऑलवेज interact and ask the doubts. This is CH3COOH. This is carboxylic acid. This is your B because that oxidation kela. Carboxylic acid. So that's the thing. So your answers are this. So हो विचारला तुमकां A आणि वो B विचारला. Next question. Arrange the following compounds in the increasing order of their reactivity towards nucleophilic addition. आता सिंपल न्यूक्लियोफिलिक एडिशन म्हटल्यार कितें, न्यूक्लियोफायल एका कार्बोनिल ग्रुपाचेर अटॅक करता आनी थंयसर न्यू बॉन्ड करता. लायक आय नॉट डिफरन्शिएट लायक आल्डिहायड ऑर अ किटोन. हांव म्हणटा एक कार्बोनिल आसा, ओके, हो एक कार्बोनिल. जनरली हांव तुका दाखयता, दिस इज अ कार्बोनिल, म्हणजे आल्डिहायड नाल्यार किटोन हो आसतलो. हेजेर पॉझिटिव्ह चार्ज आसा, ह्या हेजेर कितें आसा, पॉझिटिव्ह चार्ज आहा. आनी एक न्यूक्लियोफायल येता खंयची तरी नेगेटिव्ह, तेजेर नेगेटिव्ह चार्ज आसा. तो हेजेर अटॅक करतलो, म्हणजे न्यू बॉन्ड करतलो आनी तुका हे ओल्ड बॉन्ड तुटतले, पाय बॉन्ड तुटतले आनी न्यू बॉन्ड फॉर्म जातले हांगा. म्हणजे तुका दीस कायंड ऑफ स्ट्रक्चर यू आर गोइंग टू गेट, दॅट इज O मायनस आनी ही न्यूक्लियोफायल. आता हितून कितें जालें, न्यूक्लियोफिलिक एडिशन जालें, म्हणजे मॅक्झिमम मोर द मॅग्निट्यूड ऑफ द पॉझिटिव्ह चार्ज मोर इज द magnitude of positive charge, more is what, more is the reactivity, more is the reactivity of nucleophile towards addition reaction. Like addition is happening over here, double bond is converted to the single bond, so addition reaction towards addition reaction. Okay, so we'll have to understand in which case there is a maximum magnitude of the positive charge and in which case there is a minimum magnitude of the positive charge. So over here if you see, this is formaldehyde, this is benzaldehyde, this is ethanol, this is propanol, means all are aldehyde. Okay, so we have to figure it out. So I'll write the structures of all. First I will write for the formaldehyde how formaldehyde looks. This is what the structure of the formaldehyde. Then there is benzaldehyde. This is benzaldehyde. Magir ethanol. This is ethanol and last aha the propanol. Okay, right, this is formaldehyde or also known as methanol. Aldehyde, it is methanol. This is benzaldehyde. See, names are not important for this question, so that you revise the names, that is also very important. This is benzaldehyde, this is ethanol, and this is propanol. हांगा पया की positive charge on every carbon there is a positive charge, on every carbon there is a positive charge, partial positive charge because of the electronegativity of the oxygen. हांगा आमकां find करपाक जाय on which there is a maximum positive charge. If you go to see over here, there is a resonance in the benzene, like maximum. First आमी minimum पळोवया, कित्याक कितें विचारला, increasing विचारला. सो हांगा resonance जाता पाय सिग्मा आनी हो पाय, आनी ह्या खातीर हो पॉझिटिव्ह चार्ज it neutralizes to more extent or maximum extent, or also हांगा ह्या केसीन न्यूक्लियोफायलाक अटॅक करपाक डिफिकल्ट जातले बिकॉज दिस इज अ बल्की म्हणजे एक स्टेरीक हिंड्रन्स तयार जातलो हांगा. त्या खातीर हांगा डिफिकल्ट जातले न्यूक्लियोफिलीक अटॅक. सो हांगा रिएक्टिविटी कमी आसतली इन वॉट बेन्झाल्डिहायड. आय रायट द नेम. द बेन्झाल्डिहायड will have least reactivity towards a nucleophilic addition. हो क्वेश्चन बरे तरेन नीट एग्जामीक जेई क्वेश्चन सुद्दां येवंक शकता. इतक्या बरो क्वेश्चन आसा. मागीर फुडें आसा नेक्स्ट आसा तो आय विल कन्सिडर इथायल. इफ यू कन्सिडर इथायल, मिथायल आनी हायड्रोजन, this creates more steric hindrance and it has better plus high effect. म्हणजे इलेक्ट्रॉन डोनेटिंग नेचर ह्या ग्रुपाचो चड आसा. कित्याक तो व्हडलो ग्रुप आनी इट डोनेट्स इलेक्ट्रॉन टू अ मोर एक्सटेंट. त्या खातीर ह्या पॉझिटिव्ह चार्ज न्यूट्रलायजीस टू अ मोर एक्सटेंट. म्हणजे हांगा न्यूट्रलायझेशन पॉझिटिव्ह चार्जाचें चड जातलें. सो तेज्या फुडें येतलो तो आमचो प्रोपेनॉल. मागीर मिथायल हो मातसो धाकटो आहा, स्टेरीक हिंड्रन्स मातसो कमी. सो हांगा अटॅक हेज्याकून हांगा चड बरो जातलो. सो इट इज इथनॉल. And maximum there is no steric hindrance. There is no steric hindrance in this case, and this is not also very strong electron donating group. It is not at all electron donating. So a neutralization of this positive charge will not take place. म्हणजे हांगा मॅक्झिमम कोणाचेर जालो आन्सर इज मिथनॉल. So this is what the answer is. This is what the answer is. Propanol, ethanol. You can write the structures also as structures are asked in the paper. So here is the question. Question asked is the compound formed by oxidation of the butane to all with a CrO3 and PCC. Understand student, over here the reagent which is given, that is CrO3 and or a PCC. Okay, either CrO3 or pyridinium chlorochromate, any one of this. This is also oxidizing agent. This both are what? Both are oxidizing agents. Oxidizing agent. So we know that if we do the oxidation of the secondary alcohol, butane 2-ol is a secondary alcohol. How do we write this? This is butane 2-ol, and this is secondary alcohol. So whenever we do the oxidation of the secondary alcohol, it gets converted to the ketone. Means if you write this CrO3 or even in the presence of PCC, what you get is this CH3, CH2, C double bond O3. So that is butane 2-ol. Your answer is this. Next question asked is, when acetone is treated with the appropriate Grignard reagent, the product obtained is a 2-methyl propane 2-ol. The Grignard reagent is asked. What Grignard reagent you will use out of the given reagents below? Okay, that is what is asked. So the Grignard reagent we have to figure out. So first we'll write the general reaction, how the carbonyl reacts with the Grignard reagent. So always remember that this is your aldehyde or a ketone, generally a carbonyl. This is the carbonyl. Okay, we are reacting this with the Grignard reagent, that is R. General way of writing the Grignard reagent is this, RMgX. So what happens over here is, when this reacts, you have to always make sure that these two bonds, you keep it intact. Okay, so this is carbon, This is carbon. What will change is over here. Now this R group, this R group, this R group is going to get combined on this carbon. So over here, this is the R group, and this changes to OMgX. Right. Now this is carbonyl. This can be what? Aldehyde. Over here, I'm talking when we say the compound carbonyl, it can be aldehyde or ketone. Means depending, like both are R and R dash, then it is a ketone. And let's say one is R and other is H, then it is aldehyde. But whatever it may be, you are keeping these two bonds intact throughout the reaction. So further, what we do is we do the hydrolysis. Further, this is what we do: hydrolysis. When we do the hydrolysis, what we get is the R connected to over here. This changes to OH. This breaking of bonds using water. And what is the other part byproduct you get? The byproduct you get is MgOHX. This is what the byproduct. Now this is the alcohol which you are getting. This is the alcohol which you are getting, right? Means depends what kind of reagent, like whether you have used aldehyde or a ketone. Depending upon that, you will get a primary, secondary, or tertiary alcohol. In this question, what they have said is one minute, students. Please hold on. Yes. So what they have said in this question is you are getting 2-methyl propanol as a final product. And what is the Grignard reagent? Means your final product is 2-methyl propanol, means it is this. I'll write over here. On second position there is methyl, 2-methyl propanol. This is what you are getting. Means you are getting a tertiary alcohol. You are getting a tertiary alcohol, or better, I will show it this way. You are getting a tertiary alcohol, and that to this. Means you see that if we relate it over here, if we relate these things over here, then if I take acetone, if I take acetone over here, I'll start with the acetone, CH3. Oh, this is acetone or propanone, that is what we say, acetone or propanone, one and same. You react this with like these two bonds, you are keeping intact, right? Means you are keeping these two bonds intact, right? So and what extra you are getting is a methyl. So what should be the Grignard reagent? Methyl, magnesium, let's say bromide, or any halide you take, in the presence of dry ether. What is the product you are going to get? Not the final, but this is the thing you are going to get: CH3 OMgBr, and this is the methyl group which is going to come over here. Further you do the hydrolysis, what you get is this compound, CH3 OH and CH3. This is what is the compound which was asked, that is 2-methyl propanol. This is 1, 2 and 3. So this is a substituent on second position. So name of this compound is 2-methyl propane tool. So in this case, what we have used? Okay, they said iodide. So I used bromine over here, not an issue. You can use iodine now. Since in the options iodine is there, you can use iodine. Any halide. So answer is what? Methyl magnesium iodide. So this is your answer. Write only the structures of the product formed when ethanol reacts with each of the following. So what is ethanol? First what we are doing is, this is an addition reaction actually. Addition reaction. So you have ethanol. Ethanol is this way. Addition reaction of the ethanol we are doing. CH3 C double bond OH aldehyde. 2 carbon. This is 1 and this is 2. This is ethanol. Okay. So you have ethanol CH3 C double bond OH, and this carbon is what? Partially positive. And you have HCN, you are adding a HCN, means HCN will give you a Cn minus ion. HCN will give you a Cn minus ion that will attack on this. And this is the pi bond which is going to break. Attack on this carbon means what? It is going to form a new bond with this, and old bond is going to break. Old bond is the weakest bond. And what you get is CH3 O minus H and Cn, right? So over here negative charge is on the carbon. Like whenever HCN breaks, it splits as H plus and a Cn. Actually minus is on the negative, and then that H was there of the HCN splits as H plus. That will combine with this hydrogen. To give you this CH3 OH. This is the product which you are getting. Second is Clemenson's reduction. Means you have ethanol, and what you do is Clemenson's reduction. Zinc, mercury in the presence of concentrated HCl. What you get over here is you just remove this oxygen and add hydrogens. So CH3, CH2, H. Means what is this? You can also write this as CH3 and CH3. Means your product is ethane over here. That's it. Next reaction is, hanga vichalla, write label chemical equation to show what happens when benzene is treated with acetyl chloride in the presence of anhydrous aluminum chloride. आता हांगा अशें जावंक शकता की तुमकां हे रिएक्शन खबर आसा, पूण तुमकां खबर ना what is acetyl chloride, because name over here which is used, it is not very most frequently used, right? सो तो प्रॉब्लम जावंक शकता. सो तुमकां हें नांव खबर आसपाक जाय, एसिटायल क्लोरायड शब्द और स्ट्रक्चर कसो आसा तो. सो हांगा आमी रिएक्शन्स करुया. सो बेन्झीन is treated with acetyl chloride in the presence of anhydrous aluminum chloride. So benzene घेता आणि acetyl chloride. acetyl chloride म्हटल्यार कितें? CH3 C डबल बॉन्ड O आणि हांगा Cl. एसिटो ग्रुप, लायक आमी केन्ना केन्ना एसिटीक एसीड कशें बरयता, याद कशें धरप हें. एसिटीक एसीड आमी CH3 COOH. दिस इज एसिटीक एसीड बिकॉज दिस इज एसिटायल ग्रुप. ओके, हेका म्हणटा एसिटीक एसीड. सो एसिटायल क्लोरायड इज दिस CH3 C डबल O ओनली इन प्लेस ऑफ OH कितें आसता थंयसर? एसिटायल क्लोरीन असता. सो दिस इज एसिटायल क्लोराइड. आणि हितून कितें घालता आमी एनहायड्रस AlCl3. सो प्रोडक्ट तुमकां मेळटा हो C double bond O CH3, right? The product name is acetophenone. The product name is acetophenone. So name of this reaction is known as Friedel-Crafts, FRIE Friedel-Crafts acylation reaction. Acylation reaction. This is what is the name of this reaction. Now किती जाता हांगा इलेक्ट्रोफाइल जनरेट जाता. इलेक्ट्रोफाइल म्हटल्यार कितें इलेक्ट्रॉन डेफिशियंट स्पीशीज which is generated by the reaction of this CH3 C double bond O Cl आणि AlCl3. ही दोगूय जाण रिएक्ट जावन तुका कितें मेळटा CH3 C double bond O plus AlCl4 minus. This is what the electrophile which gets substituted on the benzene, and this is what the product you get over here. Okay, so this is what the product which was asked for 1 marks, and the product name is acetophenone because it is a ketone. What product you are getting is acetophenone, that is a ketone. Next reaction is state the name of the reaction in the following conversion. तुम्ही हांगा पळोवपाक शकता की हांगा रिएक्टंटान कितके 2 कार्बन असले and that is getting converted to what 4 कार्बन आणि हांगा डायल्यूट NaOH घातला. म्हणजे हे स्ट्रेट एक्झाम्पल ऑफ अ aldol condensation. This is a good example of the aldol condensation. Okay, हे जालें नेम ऑफ द रिएक्शन. बट एक्झॅक्टली कशें जाता तें आमी पळोवपाक जाय. कित्याक अशें तें स्ट्रेट हेच एक्झाम्पल येतलें अशें ना. aldol कंडेन्सेशन कशें जाता पयलीं एक्सप्लेन केला, आनी एकदां शिकपाक शकता. First, there are two molecules of the ethanol dila. So first step, generation step 1 maybe haven't he kela astale पहिली. Step 1 is generation. 1 minute, I'll check if it is done earlier, then there is simply no point in solving this. म्हाका दिसता पयलीं आसलें एक रिएक्शन आनी थंयसर हांवें केला aldol कंडेन्सेशन. Just hold करा. As far as I remember, I think I have done one aldol condensation. Yeah. म्हणजे टील aldol सुद्धा केला पळय, हांगा केला हांवें तें. ओके, हांव तें परत करता, नो इश्यू, बिकॉज द फर्दर डिहायड्रेटेड प्रोडक्ट इज ऑल्सो आस्क इन दिस. So step 1 is a generation of nucleophile. Step 1, generation of nucleophile. So हांगा 2 आसा मॉलिक्यूल. हांगा कितके आसा 2 मॉलिक्यूल आसा कोणाचे इथेनॉलाचे. सो एक फर्स्ट मॉलिक्यूल हांव यूज करता. 2 सो CH3 हांव असो बरयता कित्याक म्हाका एक अल्फा हायड्रोजन काडपाक जाय भितरलो. So how do I understand? This is the functional group. So this is alpha carbon and this is alpha hydrogen. This is how we understand. आणि हांगच्यान OH मायनस हांव कितें करता हांगच्यान काडटा आनी एक न्यूक्लियोफायल जनरेट जाता. कित्याक OH मायनस जेन्ना H प्लसाचेर अटॅक करून ताका भायर काडटा तेन्ना तो H प्लस म्हणून भायर येता. सो तेजेर कितें उरतलो CH2 मायनस आणि C डबल बॉन्ड OH. सो ही तुजी न्यूक्लियोफायल जनरेट जाल्या. दिस इज द न्यूक्लियोफायल विच इज जनरेटेड. आता फ्रेश मॉलिक्युलाचेर तो अटॅक कर. इथेनॉल हांव परत CH3 C डबल बॉन्ड OH हांव हो H हांगा बरयता कित्याक म्हाका अटॅक करपाक सामकें बरें पडटलें. सो हांगा असो बरयता सेम ते. आतां न्यूक्लियोफायल कसो बरयतलो हांव ती जनरेट जाल्ली ती. दिस इज द न्यूक्लियोफायल which is generated. This is generated. I am removing the carbon in this case, you see, from the alpha hydrogen. हांगच्यान काडला हांवें तो अल्फा. सो त्या प्रमाणे म्हाका ही न्यूक्लियोफायल मेळ्ळ्या. आनी हांगच्यान हांव हांगा अटॅक करता ह्या कार्बनाचेर आनी म्हाका कितें मेळटा ऑब्वियसली हे बॉन्ड तुटतले पाय बॉन्ड वीक आसता ते तुटतले आनी आमकां CH3 COO मायनस a hydrogen CH2 C double bond OH. Further this gets converted to OH. आता तुजे कडेन हो कंपाउंड आसा तो आमकां डिहायड्रेट करपाक जाय. दिस इज जस्ट आल्डॉल. कंडेन्सेशन जावना अजून. You are getting a aldol. Further we need to dehydrate this. You are heating this compound. You see there is a heat symbol. म्हणजे आमकां एक अल्कीन फॉर्म करपाक जाय. सो हांव तुमकां जस्ट दाखयता हाऊ टू फॉर्म द अल्कीन. देर आर टू पॉसिबिलिटीज ऑफ द फॉर्मेशन ऑफ द अल्कीन. So copy and paste. Okay, this is hydrogen. Okay, आणि हांगा हांव एक सॉरी परतूच बरयता तो स्ट्रक्चर. आमकां हो मेळ्ळा आल्डॉल मेळ्ळा. आतां फर्दर आमकां तो हे करपाक जाय. हांगा एक हायड्रोजन आसा, हांगा OH आसा, हांगा CH आसा, CH2 हांव असो बरयता आनी C डबल बॉन्ड OH. Further what you are doing is dehydration. Further what you are doing is a dehydration. Try understanding this. This is very simple to understand which one to write the major product. There are two possibilities for this. We have to write the most stable and the major one. So हांगच्यान हांव डिहायड्रेट म्हटल्यार वॉटर काडप. OH आनी H म्हटल्यार एक सेट ऑफ वॉटर. नाल्यार तूं हो एक सेट काड. म्हणजे हांव हेका ह्या सेटाक काडलो जाल्यार A म्हणून बरयता आनी ह्या सेटाक काडलो जाल्यार B बरयता. सपोज हांव A सेट काडीत वॉटर मिन्स मायनस H2O करीत हांगच्यान डिहायड्रेशन करीत जाल्यार म्हाका CH2 CH C डबल बॉन्ड OH. आनी सपोज हांव B सेट काडटा जाल्यार म्हाका CH3 CH डबल बॉन्ड C डबल बॉन्ड OH. सो तुका हांगा एक अल्कीन मेळटा. यू गेट वन अल्कीन इन दिस केस. यू हॅव टू जस्ट कमेंट एंड टेल मी दॅट विच अल्कीन इज मोर स्टेबल. ही अल्कीन फर्स्ट ए अल्कीन सॉरी अल्कीन म्हणजे आल्डिहायड प्रोडक्ट डिहायड्रेटेड प्रोडक्ट मेळटा तो. ही A काय B मोर स्टेबल. खंयची मोर स्टेबल आहा ती आन्सर करा आनी कित्याक मोर स्टेबल आसा ते आन्सर करा. पॉज द व्हिडिओ फॉर सम टायम एंड यू कॅन कमेंट. So I'll tell you why which one is more stable. This is more stable. This is more stable alkene. More stable alkene. And this is less stable alkene. Why? कित्याक? कारण हांगा pi sigma sigma pi हांगा conjugation ना. There is no conjugation. But here if you see pi sigma pi means conjugation. Whenever there is anything is in conjugation that is most stable. So therefore this is the answer and that is what they have shown. B. हांगा रिएक्शनान कितें दाखयला हे विचारलं होच प्रोडक्ट मेळटा आमकां त्या खातीर हे आल्डोल कंडेन्सेशन. जस्ट नांव विचारलेलें आयडेंटिफाय करून आल्डोल कंडेन्सेशन बरयलें तुमकां एक मार्क्स मेळटलो. पूण हे मेकॅनिझम आनी कशें जाता तें समजलें जाल्यार बेस्ट. तुमकां हो आन्सर हो क्वेश्चन JEE और नीट एग्जामीन सुद्दां बरे तरेन विचारलो जावंक शकता. नेक्स्ट क्वेश्चन इज रोड मॅप क्वेश्चन. बेसिकली पीपल सिम्पली गेट स्कॅर्ड बाय looking at this roadmap question. Many students leave this question thinking that this is something which is impossible. See, roadmap questions are not very tough. It is simple if you know the other reactions. If you know the in and out about that chapter, then it is very easy. So here I will read this question. An alkene having molecular formula C5H10 upon ozonolysis and further decomposition with zinc and water forms compound B and compound C as product. Compound B gives Felling's test as well as positive iodoform test. Compound C gives a positive iodoform test and not the Felling test. Write the appropriate chemical equation involved in the formation of the compound B and C from the alkene. Also write the name of the also write the names of the compound B and C. So we have to understand what is exactly the ozonolysis reaction. See, there may be a different mechanism, different thing, big things on the NCERT, but I'll tell you the simple trick. See, any alkene which is there, you have to represent across the double bond. Let's say you have the alkene Example, we want a alkene which has a 5 carbon 10 hydrogens. Okay, a possibility could be what? It could be this possibilities. We'll write the possibility of this alkene. One possibility is, this is the alkene, CH2. The other possibility is this. Okay, these are the only two possibilities. Means you will say that I will shift this double bond over here, then it will be same as this. Means I am shifting this double bond over here. So both these alkenes are same, and now you shift it over here last, then it will be again same as this. So there are just two possibilities of the alkenes. Now what we'll do, we'll form the double bond. We'll write this. How do we write? See, ozonolysis reaction, first I'll explain you. This is the ozonolysis reaction. If there is a double bond, you show this alkene this way. Okay, I'll say this is A group, this is B group, this is C, and this is D. Ozonolysis followed by decomposition with zinc and water will give you this. Means reagents required over here, this is ozone, second zinc, and water will give you this. I'll write P and Q. This is P, this is Q, double bond O. Over here A, B, and double bond O. Now whether this is aldehyde or ketone will decide on this, will depend on this. If both are R, then it is a ketone. If one is R and other is H, then it is aldehyde. Also this side also, it will depend upon whether it is aldehyde or ketone. It will depend upon what? P and Q group. Now we'll take the first alkene. Across this I will write. This is the first alkene. This is hydrogen. This is CH2, CH2, CH3. This is hydrogen, hydrogen. You do the ozonolysis. You are breaking this bond and putting oxygen. This is a trick, not the concept, understand? You are doing the ozonolysis, same reagents you are putting, and what you get is the aldehyde this way, and other will be this. Means both the compounds what you are getting is aldehyde. This is ethanol, this is methanol, and this is butanol. Both are what? Aldehyde. Both are aldehyde. And what they have said in the question? Both are aldehyde. You get two products B and C. Let's say this is our A, this is our B. I am not saying at any point that what I am doing over here is correct. I am just telling the possibilities A and B. So B and C किती झाले तुमचे? Compound B gives a Felling's test as well as iodoform test positive. Okay. So let's say this is B. Ho Felling's test positive ditlo. Why? Because it is a aldehyde. Felling's test is positive because this is aldehyde. Since it is aldehyde. Iodoform test negative. Because there is no methyl group. At least one methyl group should be there on a carbonyl. Right? Sorry. Yeah, true. Iodoform test negative. Compound B gives Felling's test as well as positive iodoform test. Okay, let's check for the other. This compound will give Felling's test positive because it is aldehyde. Positive. And iodoform test is again negative because this is a propyl group, not the methyl. If it is a methyl group, any one methyl group, then you get iodoform test negative or positive mean. So iodoform test negative. So this is not that alkene. This is, so we understand that it is not satisfying the condition. So this is not that alkene we are looking for. I think we should be looking for the second alkene. If I go for the second alkene, the alkene was this. This was the second alkene, right? If I write across the double bond, there is a hydrogen, there is this, CH3, this is hydrogen. Means you do the ozonolysis of this, and what you get means ozonolysis followed by decomposition in zinc and water. So this is the aldehyde which you are getting over here. This is CH3, and other aldehyde what you are getting is this. So both are aldehyde, like one is ethanol and other is propanol. Okay, so here since it is aldehyde, Fehling both for both the aldehyde, since both are aldehyde, Fehling's test is positive. So I'll write Fehling's test is positive. Here also Fehling's test is positive because both are aldehyde. And what about iodoform test? Iodoform test is positive only for this because there is one methyl group over here, and for this iodoform test is negative because this is not a methyl, this is the propyl. So this is the simple thing which was asked in an examination, like question was about this. So you are getting this as the answer. So what you are writing for the exam is this. So you are told to identify A, B and C. So this is your A, this is your B and this is your C. So you should write the name of that compound and everything. Then you will get this 2 marks. Next question asked over here is in that same sub question, this is given, this compound. So what is the name of this? This is acetone. If we open up this structure, it is this way: CH3, C double bond O, CH3. And zinc mercury is given. Over here, this reagent is given, zinc mercury. Now this reagent tells you that this is a Clemenson's reduction. What is this? This is Clemenson's reduction. I'll write over here, name of the reaction. I'll write over here. This is question 2, no? Sub question. That is, it is Clemenson's reduction. Clemenson's reduction. Why it is called Clemenson's reduction? Because there is removal of this oxygen and the addition of the hydrogen. Means what exactly you get in this reaction? The reaction is very simple. Compound Q will be CH3C. Remove this hydrogen and put 2 hydrogens over here. Means propanone gives you what? Propane. So your compound Q is propane. So this is what the answer is. This is what your answer is. Second reaction over here given is third reaction about the same sub question is nitration. This is nitration of benzaldehyde. Now this falls under the category of electrophilic aromatic substitution. What is this? This is electrophilic aromatic substitution, where the product will depend upon the directive influence of this group. If you look at this group closely, uh, if you look at this group closely, this is ortho-para-directing. This group which is present over here, this is ortho-para-directing to incoming electrophile. So over here in this case, the electrophile generated is NO2 plus. So sorry, I made a mistake over here. This is not orthopara. It is meta directing. Sorry, this group is meta directing. So where the incoming electrophile will go? Incoming electrophile, if this is your aldehyde, then this is meta position. So you are getting meta nitrobenzaldehyde. This is meta nitrobenzaldehyde S product. So your answer is meta nitrobenzaldehyde for this. Now compound S gives you, in the presence of soda lime, gives you ethane. This soda lime reaction, it is a decarboxylation reaction. I'll write the name of this. This is decarboxylation reaction. Now how is this reaction given? What is soda lime? The carboxylation reaction is given this way. General reaction, if you write COO minus sodium salt of that particular respective acid. Soda lime is what? Sometimes they write a soda lime, or they will just write NaOH plus calcium oxide. And after decarboxylation, what you get is RH plus Na2CO3. This is what the product means. You get the alkane which has one carbon less, than reactant. So if you are getting a ethane, then this is 2 carbons. You should have the salt of S, which should be having 3 carbons. So what should be that salt? It is this CH3, CH2, CO minus, Na plus, and you have soda lime. That is, you write this. This is same as what? Soda lime. So you write soda lime. Okay. And decarboxylation. Decarboxylation means you are removing this carbon dioxide. Removal of carbon dioxide. Decarboxylation. Removal of carbon dioxide. So what you get is CH3, CH2H, which is same as CH3, CH3. Means this is ethane plus Na2CO3 as the byproduct. So what is your answer as S? This is your S. So you are writing their answer as this highlighted part. This is the highlighted part you are writing as an answer. So name of this is sodium salt of, the name of this compound is sodium salt of propanoic acid. That's it. Next question over here asks is select the compound that is most reactive towards the nucleophilic addition from the following compound. See, what is nucleophilic addition? See, addition is the reaction which take place across the double bond. Let's say this is your carbonyl. I'll not name this whether this is aldehyde or a ketone. Just consider this as the carbonyl. It can be aldehyde or ketone. Addition reaction. Let's say you have the nucleophile as a OH minus. This is the nucleophile which is electron rich. Nucleophile is always electron rich. What it will do? It will attack on this carbon only, because this carbon is partially positive because of the presence of this oxygen, electronegative element, right? So it will attack, means it will try to form a new bond, addition product. And in that case, the weakest bond is going to break. So this is the pi bond. One of the pi bond is the weakest bond, which is going to break. So what do you get over here is the addition product. I will write over here this addition product as this carbon. This changes to O minus, and let's say this is new OH, and this is the thing. This is what you get over here. So this is the addition thing. Now the question is, more is the magnitude of the positive charge over here. More is the magnitude. More is the magnitude of positive charge on carbonyl carbon, on carbonyl carbon. More is the reactivity. More is the reactivity of it towards nucleophilic addition. Now, if I ask you in general, if I categorize the aldehyde and the ketone thing, if I categorize the aldehyde and the ketone thing, over here I'll write, this is the aldehyde, this is how we represent aldehyde, this is how we represent ketone. Both R and this R dash can be same or may not be same, right? Over here also there is a partial positive charge, over here also there is a partial positive charge, in which case the magnitude of the positive charge will be maximum. Now this is a very simple thing. You can comment and you can tell me, I'll call this as A and this as B, in which case the magnitude of positive charge will be maximum. You can just comment in a comment section. Okay, pause the video for some time. Okay, the answer is this magnitude is higher than this, because here there is only one electron donating group, here there are two electron donating group. So because there are two electron donating group in this compound, there is a more neutralization of the positive charge, and here there is a less neutralization of the positive charge. Therefore nucleophilic addition is nucleophilic addition is better in aldehyde compared to ketone, Now the thing is, so obviously there are, what are the compounds given over here? Acetone is a ketone, then there is a aldehyde and propanaldehyde or propanal. So obviously ketone will have, because it is in the acetone or a ketone family, that's why its nucleophilic addition will be less, reactivity will be less. We have to choose between acetaldehyde and propanaldehyde. So I'll draw the structure of the acetaldehyde. Acetaldehyde is this CH3 C double one O. This is acetaldehyde. Propanaldehyde or propanal is this C double bond OH. Now over here if you see, there is smaller plus I group, here there is bigger plus I group. So what happened here? There is bigger plus I group, bigger group. Bigger group means what? More steric hindrance to incoming nucleophile, from where it will come. There is a lot of traffic because of this group, bigger group, and its donation power is also more. That's why this plus delta is smaller than this. So nucleophilic addition is better over here. So your answer is what? Your answer is ethanol. Okay. Next question asked is some name reactions are there. Preparation of the acetophenone by Friedel-Crafts acylation reaction. Now, how do we do this Friedel-Crafts acylation reaction? Friedel-Crafts acylation reaction second question number 2 sub question, that is I write the chemical equation involved. Sorry, there is one more question. Write the chemical equation involved in a sodium acetate is heated with soda lime. So this is decarboxylation reaction. Second reaction is decarboxylation reaction. Decarboxylation reaction. What is decarboxylation reaction? It is removal of carbon dioxide from carboxylic acid or its salt, right? So it is ethanoic acid, right? Sodium acetate means what? CH3CO O minus, this is sodium acetate. Soda lime means calcium oxide. Soda lime means sodium hydroxide plus calcium oxide. Sodium hydroxide plus calcium oxide. This is together called as a soda lime. You heat this compound, you get CH3H plus Na2CO3. And what is this compound? This compound is a methane. It is as good as writing CH4, right? Means what is done? Decarboxylation. There is a removal of this part. There is removal of carbon dioxide and hydrogen is being attached. Removal of COO minus, right? That is what a decarboxylation reaction is. The third reaction is preparation of acetophenone by Friedel-Crafts reaction. So second AL, right? Preparation of acetophenone by Friedel-Crafts acylation. Means what is structure of acetophenone? See, general way of general reaction, I'll write. General Friedel-Crafts reaction. It is this. You have benzene, you have acyl group RCOCl in the presence of anhydrous AlCl3. What you get is this kind of ketone. You get this kind of ketone, right? Now you want the compound to be what? Acetophenone. This aceto group, C double bond O CH3. This is aceto and phenyl ring, so it is acetophenone. You want this acetophenone. So what should be this? I am going reverse in this reaction. Anhydrous aluminum chloride. So what should be this? This is the benzene and this should be CH3 C double bond O Cl. Means benzene and ethanoyl chloride. This is ethanoyl chloride. Last reaction is preparation of bromopropanoic acid by Hell-Wohlard-Zielinski reaction. Bromopropanoic acid by Hell-Wohlard-Zielinski reaction. B I'll write. Hell-Wohlard-Zielinski reaction. So you should know the general reaction what is given over here. There is a substitution of the halide on a alpha carbon. Means if this is your carboxylic acid, if this is your carboxylic acid, so therefore this is your alpha. On this alpha there is a substitution of the halogen. That clarity you should be having. The reagents will be what? Reagents, one use is halide like Cl2, Br2 in the presence of red phosphorus and water. What you get is R, CH, X, COOH. But you are asked, they did not ask you this general, they ask you about the bromopropanoic acid. Bromopropanoic acid means CH3, CH2, COOH. This is your propanoic acid. This is your propanoic acid. If you use this same reagent like Br2 instead of X2, you are using Br2 and red phosphorus. Second is water. What you get is CH3, CH, Br, COOH. So this is what is asked. This is the question. First question is the product formed in aldol condensation is okay. We'll understand what is aldol condensation. I'll take the simple example of the aldol condensation and let us understand later which of these options are correct. So I'll take the simplest of the aldehyde. Simplest means CH3, like 2 carbon system, that is this is the aldehyde and I want to do the aldol condensation of this. Means I will take another fresh molecule and like basically aldol condensation involves I will say 2 steps. One is generation of the nucleophile. First is it involves the generation of the step 1 is generation of nucleophile. Means if your aldehyde is this, okay, if this is the aldehyde, we will write it this way. CH3 I will write this way. I am removing the alpha hydrogen from here. Alpha hydrogen is the one which is present on an alpha carbon. Like this is alpha carbon. Why? Because it is connected to the functional group, right? So over here this is the alpha hydrogen. I am abstracting as a from the OH minus, right? And it will go as a H plus. So there is a generation of the nucleophile. On this there is a negative charge which will be formed. And this is our nucleophile. This is our nucleophile. What is step 2? Step 2 is addition of this nucleophile. Addition of nucleophile across carbonyl carbon. Means take again a fresh molecule of the aldehyde which you had taken, C double bond OH. I will show this hydrogen downside. Okay, for me the attack will be better. So this is the nucleophile which is generated, and if you go to C over here, this will attack on this carbon because this carbon is partially positive. This pi bond will change it change to OH minus, O minus, then further it will change to O minus. So actually this is changing to O minus at this point. This is hydrogen, this is CH2, C double bond OH, and this O minus later changes to what? H. Now there are 2 functional. This is our aldol, this is our aldol. Means it is aldehyde plus alcohol over here, alcohol group. That is what the aldol means. This is the aldehyde group, functional group, and this is our alcohol, right? 2 functional group. Whenever there are 2 functional group, this is the principal functional group. Over here, aldehyde is a principal functional group. We'll call this to be hydroxy. Means this is the functional group connected to this carbon. This is alpha, and next carbon is beta, on which OH is there. And this is our aldol. We'll call this to be what? A beta hydroxy aldehyde. This is the answer for this. Next question, question number 6, and it is for the 4 marks. There are 4 reactions given. I'll explain this very simple reaction. So over here reaction given as I'll write the reaction. So they said there is compound P is there. This gives you, in the presence of dilute NaOH, what you get is CH3 this is what you are getting. Okay, how to identify what reaction is this? In this, the examiner is not telling you to find the reactant, product. Here what is the thing you need to find? You need to find the reactant, what reactant it is, right? We don't know what it is, but here the product is given. As this. Can someone tell me what is this product called as in general? You can comment what product is this. Okay, product. Pause this video for some time and try to figure out what reaction it is. Reaction is not straight. So if you go to see over here, there are 2 functional groups in this. One is alcohol and other is aldehyde. So whenever there are 2 functional groups, the aldehyde and the alcohol, this is together called as what? General name, not a specific name of this. This is called as aldol. Aldol means what? Aldehyde plus alcohol. These functional groups are present. This is called as aldol. So it is aldol means we have to know that this is the compound where the starting reagent is aldehyde, right? And it is, if you go to see like which aldehyde, you see that over here this is getting converted, this one part where OH is connected, and this is the another part of that compound. Okay, so your aldehyde should contain a 3 carbon. See, there are total 6. So if you make it half, your aldehyde should contain 3 carbon, right? So that is how we identify which aldehyde it is. So basically aldol is the product you get by combining 2 molecules of the aldehyde. So if I go by this, I'll write the steps of the aldol condensation. Step 1 is generation of a nucleophile. Okay, how do we generate this? By removing or abstracting, removing alpha hydrogen. Now you know by now what is alpha hydrogen. You consider the aldehyde. Let's since I know that there are 6 carbons in a product, so there will be 3 in what? Reactant. So I'll write the aldehyde with the 3 carbons, CH2. This is the aldehyde. If you go to see, this is the functional group. If you go to see, this is the functional group over here, and this is the functional group, and to this what is connected? The first carbon, this is alpha and this is beta. You are abstracting the hydrogen from this alpha carbon. So if you abstract the hydrogen from this alpha carbon,
I'll still write it this way. This is the hydrogen, and what is there? OH minus is there. You are abstracting it using that base, and you get the nucleophile as, since hydrogen is gone as a H plus, it will leave away its electron over here, so it has a negative charge. This is your nucleophile. This is your nucleophile. What is step 2? Using this nucleophile, do the addition reaction. Okay, means step 2, you are writing this nucleophile, okay, understand? This is my nucleophile which I am getting. So addition reaction on a fresh molecule, like you write a fresh molecule this way. I'll write this aldehyde fresh, like it is not that reaction means there is only one molecule, there are a large number of the aldehydes. So I'll write it this way: CH3, CH2, C, double bond OH. But what I write over here is this hydrogen I will write down. It is the same thing. Now over here also I am writing it. This is the nucleophile CH, C, double bond OH, and this is the negative charge. This is the nucleophile. But what I'll do over here, for me the attack should be easy, I should be understanding. So this CH3 I am writing over here this way. Now simply you have to connect it over here. This will form a new bond between this carbon and this carbon. Okay, so this was possible because I aligned. Alignment is very important. If you write it CH3 here, then there will be a confusion. So I am doing this alignment. So whenever it is connected over here, the pi bond will break. Means you are getting this as a product: CH3, CH2, C, O minus. This hydrogen I am writing as it is. Then this is CH, this is CH3, COH. Later this O minus will change to H in aqueous medium, right? And this is what the product is. That is what is asked. This is what the product you are getting over here, and we are getting also same thing. So what is the P? The P is this. How did we figure out? By counting the number of the carbons in a product. So half of it will have over here. So this is our P product. So you should be writing P is this: CH3, CH2, C double bond OH. So here the question asked is alcohol getting converted. This is the alcohol getting directly converted to the carboxylic acid. Means you remember that there is one simple flow. Many times I talk about this flow or the flow chart. Primary alcohol, if you oxidize primary alcohol, if you do the oxidation by using any oxidizing agent, it will get converted to, like mild oxidizing agent, it will get converted to aldehyde. And if you oxidize aldehyde, if you do the oxidation of aldehyde, then what you will get is a carboxylic acid. Now from alcohol to get a directly a carboxylic acid, you require a strong oxidizing agent. And if you use a mild oxidizing agent, your reaction will stop at aldehyde. Again you have to do oxidation, right? So here the strong oxidizing agent which can be used is a KMNO4. It can be KMNO4 in the acidic medium, or you can also use CrO3, okay, chromic oxide, in acidic medium. Okay, like this is also called as a Jones reagent. Now this is next, you are getting a carboxylic acid, and this is also a alpha substituted. This carboxylic acid which you are having over here, this is the functional group and this is the alpha. So this reaction from converting a carboxylic acid to alpha chloroproponic acid, that is alpha halogen uh, carboxylic acid, this name of the reaction is Hell Wallard Zelinsky reaction. Zelinsky reaction, right? The reagent used is halide. Like since it is Cl, it is Cl2 in the presence of red phosphorus. That's the reagent. Which product, a proponic acid or a chloroproponic acid, has more acidic strength? They are asking whether proponic acid or a chloroproponic acid, which has more strength. So proponic acid, I'll write the structure. Second part of that question. This is proponic acid, COOH, and chloroproponic acid, alpha chloroproponic acid. Alpha, why it is? Because chlorine is present at a alpha carbon, because this is the functional group. This is the functional group and this is alpha, right? So over here, which is more acidic? Now, when this will act as an acid, we will write this as CH3, CH2, COO minus, H plus. And over here, this is CH3, CH, Cl, COO minus, H plus. Always remember that negative charge over here or over here is stabilized by electron withdrawing group. So chlorine is what? Chlorine is electron withdrawing group because of its high electronegativity. This is electron withdrawing group. EWG means what? Electron withdrawing group. That's why this negative charge is more stable. That's why this hydrogen will leave very easily and there will be more formation of the H plus. That's why alpha chloroproponic acid, alpha chloroproponic acid is more acidic than just propanic acid. Next question asked is over here, this compound, that is benzoic acid, is converted to meta-bromobenzoic acid. This is what the question is. The question is very simple. Actually, this reaction falls under the category of electrophilic aromatic substitution. Aromatic substitution. What is the meaning of this? The electrophile is substituted on the benzene. Electrophile is substituted on the benzene. Now, what is the electrophile? Br is the electrophile. Br is electrophile. This is being substituted, right? So the reaction is this way. Bromination. It is called as bromination. Now this is COOH, benzoic acid. This is benzoic acid, and what you are doing is bromination, means Br2 in the presence of anhydrous Fe, Br3 you are using, and this will generate the electrophile and it will direct incoming electrophile. Who will direct incoming electrophile? This group will direct incoming electrophile to meta position, because this is meta directing group. So you have to know which groups are ortho, para, meta directing. So this is meta directing group. So obviously the Br will come over here. Write the reagents is used. So what is asked? These are the reagents. So question is asking about the reagent. So what are the reagent? These are the reagents. Br2 F anhydrous Fe Br3. So the compound what you get, will write the name. This is meta bromo benzoic acid. Write a label chemical equation to show benzyl chloride is hydrogenated in the presence of palladium and barium sulfate. So I'll first write the reaction, then I'll name this benzyl chloride. First, you should know what is benzyl chloride. Okay, you can write it this way or you can write here also. This is what the benzyl chloride is. This is benzyl chloride. Okay, and what is done? It is done hydrogenation. This is done a hydrogenation, means reduction is done, and that is partial reduction. How do we understand? Presence of palladium and the barium sulfate. In the presence of palladium plus barium sulfate. Okay, so this reagent which is there, palladium plus barium sulfate, this is also known as a Lindlar's reagent. Lind This is known as a Lindlar's reagent. Lindlar's reagent. Okay. For exam, they may not give you palladium plus barium sulfate. They may just write a Lindlar's reagent. You have to know both a barium sulfate and Lindlar's reagent. So what happens is a reduction till where it reduces. This is a derivative of an acid. So it doesn't go reduction till alcohol. It reduces till aldehyde. And what you get is a benzaldehyde. The product is benzaldehyde. Okay. State the name of the reactions of the following conversion. This reaction is again electrophilic aromatic substitution, and this name is a Gattermann-Koch reaction. Gattermann-Koch reaction. So this is the electrophile which is generated due to reaction of the HCl and carbon monoxide. So this is the electrophile which is generated, and that is being substituted on the benzene. Okay, and you get this product, a benzaldehyde. Here this question is saying that write the chemical equation for the preparation of oxime from acetaldehyde. So this reaction, I would say the carbonyl general reaction is represented this way. General reaction is represented this way. That this is carbonyl, and any nitrogen, we say amines. I'll say this is NH2 and Z. Okay, like over here, what is Z? If it is ammonia, then Z is H. Okay, depends. If it is amine, then Z is R. If it is hydroxylamine, then Z is OH. Right? So this forms the addition reaction. This forms the addition reaction. There is a lone pair over here, and you see that this is a carbon which is partially positive. So obviously it will attack over here on this, and it forms the intermediate. It forms the intermediate like this. These carbons, this changes to OH, and this is NHZ. Means at the end, you don't worry about the in between, what is happening. You just write at the end, you are getting NZ and H2O. Right? What they have said about the oxime, preparation of the oxime from acetaldehyde. Now, what is oxime? Oxime is something which is from the hydroxylamine. And what they have said? Starting from the acetaldehyde. Acetaldehyde, see, it's very simple. Acetic acid is what? CH3COOH. Those who, like many students know acetic acid but don't know acetaldehyde. Like जेन्ना हांव क्लासीन शिकयता भुरग्यांक तेन्ना म्हाका समजता की भुरग्यांक एसिटीक एसीड म्हटल्यार खबर आसा, पूण भुरग्यांक खुबश्या भुरग्यांक एसिटाल्डिहायड खबर ना. फक्त कितें करपाचें, एसिटाल्डिहायड म्हटल्यार हो तुजो CH3 COOHच्या जाग्यार तुमी CHO घाला. This is your acetaldehyde. So what is acetaldehyde? Acetaldehyde acetaldehyde is this CH3 C double bond OH. I am writing it in this format carbonyl. This is H. So finally oxime मेळटले जाल्यार तुमकां कितें घेवचें पडटली हायड्रॉक्सिल अमाइन NH2OH. Okay, I'll just rearrange this. I'll rearrange this and write NH2. I am writing this way. Means at the end, what you are doing is you are removing this part. Understand? You are removing this part, that is H2O, and you are connecting. You are connecting NOH. This is a short trick you can remember of the oxime. So this is oxime of acetaldehyde. This is an oxime, not oxide, oxime of acetaldehyde. That's it. Okay. Next is write Itard reaction with methyl benzene. Okay, Itard reaction you need to write with methyl benzene, and then there is a Clemenson's reduction of the acetone. So Itard reaction. So Itard reaction, what it says? What is Itard reaction? Itard reaction is you take any alkyl benzene. Okay, like basically if you start with a toluene, you start with a toluene, you take toluene or methyl benzene and chromyl chloride CrO2 Cl2 and cesium, you get a chromium complex. Okay, you get a chromium complex. It is this way: CHOCrOHCl2 twice. This is chromium complex. Further, after hydrolysis, this symbol is for the hydrolysis. This is hydrolysis, breaking of the bonds using water. So what you get is the aldehyde. In this case, you are getting a benzaldehyde. You get benzaldehyde. Second reaction asked is Clemenson's reduction of the acetone. So Clemenson's reduction, like these are name reactions directly. Clemenson's reduction. There is Clemenson's reduction of what they have said. It is about the acetone. So acetone I'll write this way: CH3 C double bond O CH3. Reducing agents are zinc, mercury in the presence of concentrated HCl. What you get is CH3. Reduction means removal of oxygen and addition of the hydrogen. So answer what you get is the propane. And don't lose marks for all this type of question. This is very simple. Okay, Clemenson's reduction. So done. Yes. Question number 7, and there are 4 sub questions. This question is for total 4 marks. Okay, we'll understand this one by one. I have written that separately over here. What they have given over here is the benzaldehyde. They have given a benzaldehyde. And you are asked what is K, but what is the thing? Other product also they have given, the sodium salt of an acid. How to identify this? Basically over here, this reaction, what is there is aldehyde. This is the aldehyde, which doesn't have a alpha hydrogen. This is the aldehyde You have to identify which do not have a alpha hydrogen or absence of alpha hydrogen. No alpha hydrogen. No alpha hydrogen. How did I figure it out? You see, this is the functional group. You see, this is the functional group, and this is that carbon which it is connected. So this carbon is alpha, and there is no hydrogen connected to it, because it is anyway it is making a valency of 4. No, this carbon is making a valency of 4. 1, 2, 3, and 4. So there is absence of alpha hydrogen. So whenever we understand that there is an absence of alpha hydrogen, and in the presence of the concentrated NaOH, you are adding a concentrated NaOH. So what reaction takes place is a disproportionation reaction. I'll explain you what is disproportionation reaction. I'll tell you the name of this as early. So this is known as a Cannizzaro reaction. The name of this reaction is Cannizzaro reaction. This falls under the category of, we call this to be a disproportionation reaction. Disproportionation reaction. Now, what is the meaning of disproportionation reaction? We'll understand what meaning of this disproportionation reaction. What is the meaning of this disproportionation reaction? The meaning of this is same species get oxidized, same species gets oxidized and reduce. This is a special type of a redox reaction where same species get oxidized and reduce. Now this is the aldehyde. This is the benzaldehyde which you are having. So if I ask you over here, with this flow chart, again we'll follow this. There is primary alcohol, and if you oxidize this, you will get aldehyde. And if you oxidize this, you will get carboxylic acid. And I'll write over here oxidation. This is a small flow chart, you should know. And a carboxylic acid, if you do the reduction, you will get aldehyde. And if you do the reduction of the aldehyde, you will get primary alcohol. Now you are here. You are over here. Okay. If you oxidize this, if you oxidize your aldehyde, if you do the oxidation of this aldehyde, what you should get is a carboxylic acid. Means over here you are going to get a benzoic acid. And if you reduce this, you get a alcohol. What alcohol? Benzyl alcohol. This alcohol you are getting, right? So one product they have said that sodium salt of an acid. This is an acid, that since this is an excess NaOH, you write a salt. Means in this reaction, your one product is this and other product is this. Means with a salt. Means our reaction, if I want to write, I'll write the reaction again. How you are going to write this? This is benzaldehyde, alpha hydrogen, absence of alpha hydrogen, concentrated NaOH, or we say concentrated alkali. KOH भी ले सकते हो. Like you can take a KOH also. KOH सुद्धा घेऊपाक शकता तुम्ही हांगा. Provided you will get a salt of potassium, right? So over here, oxidized product, reduced product, one is alcohol. So alcohol, this is what is CH2OH. This is benzyl alcohol. Plus, what is the salt they have said? Actually, you should writing a carboxylic acid, COOH, but that again reacts with a base and you get a salt, Na plus O minus, sodium salt. This is a sodium salt of benzoic acid. So same species. If you go to see, to be in more precise, what is happening over here is that this is reduction. This is reduction, and same species is getting, this is what, oxidation. So this is what the disproportionation reaction you have to understand. Second, what is asked is palladium in the presence of barium sulfate. Palladium in the presence of barium sulfate. So this reaction is directly a name reaction. You have to remember the name reaction. Name reactions are important. So over here, this reaction name is where palladium and barium sulfate is used. This is called as a partial reduction of the acid chloride. Or I'll write the name first. The name of this reaction is Rosenmund reaction. This is called as partial reduction. Partial reduction. Why partial reduction? That your acid which is there, it is, you are not doing fully oxide, or acid halide is there, acyl halide which is there, you are not fully reducing it. If you are reducing it fully, understand, if you are doing this reduction completely from acid, it will change to alcohol. You are partial, you want to stop the reaction here, understanding? So over here, that's why it is called as partial reduction. Means this is the carboxylic acid which is there, or acid halide it is. So since you are getting this as the product, what should be this? This is CH3 C double bond O Cl. This is called as ethynyl chloride. Ethynyl chloride. So this is the starting, very simple reaction. You are getting a ethanol over here. Always write the names of the product, reactant. It impresses more the examiner. Next reaction asked is this. The name of this reaction is a Friedel-Crafts acylation reaction. I'll write Friedel-Crafts acylation reaction. Again, this reaction falls under the category of what? Electrophilic aromatic substitution. Electrophilic aromatic substitution. If you go to say, you want to substitute the electrophile on the benzene. You are substituting the electrophile on the benzene. So basically this reaction takes place in a two step. I'll write step 1. You don't have to write these steps, you have to just write the product. I'm telling how to reach that at product M. Step 1 is generation of an electrophile. Generation of an electrophile. That is, you have CH3 C double bond OCl. When, since Cl is a very good leaving group, you are using the anhydrous aluminum chloride, which is a Lewis acid. This gives you the electrophile this way, C double bond O plus and AlCl4 minus. So this is the electrophile. This is the electrophile which is generated. Step 2 is what? Step 2 is substitution of electrophile on benzene. So this is your benzene and this is the electrophile. What you get is, you can substitute anywhere since there is no any group present on this, all positions are equivalent. So this name is acetophenone. Acetophenone. So your answer is M over here is acetophenone, means you are writing it this way. That is your M. Last reaction over here, fourth reaction. This reaction is the hydrolysis. If you do the hydrolysis of the amide, what you get is a carboxylic acid. Over here directly, you are going to get the compound as C double bond OH, a benzoic acid. Benzoic acid. So it's very simple. You have this. What is the meaning of hydrolysis? Breaking of bonds. I'll show it here. Breaking of bonds using water. So H plus which is there, or OH minus which is there, it will attack on this carbon, and H plus will be attacked by this. So what you are getting? This bond will break. This is how the hydrolysis happens, and you get COOH plus ammonia as a gas byproduct. Next question. Question number 3, and question asked is select the carboxylic acid from the following having the highest acidic strength. Okay, first what I'll do is I will write the structure of the acids. What you do, you can pause this video and try drawing the thing. See what happens when you watch video. It is a passive learning. There should be some active learning. Active learning means that you are participating in the learning. I know that I am not in front of you, my just voice is coming over here, but try understand. Just imagine that you are in a class and you are following a teacher. What do? Pause this video, try doing by yourself, then you can go ahead with the video, comment your answers. Okay, try doing that. It helps you to participate actively in the class. So I'll write the structures of these compounds first. So first is 4-nitrobenzoic acid. This 4-nitrobenzoic acid, it is a benzoic acid. This is benzene and carboxylic acid. At fourth position there is a nitro group. So since this is a functional group, this is 1, this is 2, this is 3, and this is 4. Therefore 4-nitrobenzoic acid. Second structure is just benzoic acid. So I'll write this as a benzoic acid. This structure is a benzoic acid. And last is 4-methoxybenzoic acid. Means this is your benzoic acid, and at fourth position there is what group? Methoxy. This is methyl and this is oxy. So this is called as methoxy group. Okay. So write the names also over here. So this is 4-nitrobenzoic acid. This is 4-nitrobenzoic acid. This is benzoic acid. And this is methoxy, 4-methoxybenzoic acid. Now understand that what is the meaning of acid? Acid means a substance which can give away its hydrogen very easily. Means when this substance is acting as an acid, I'll just rearrange this. I'll write it over here this way. When these substances are acting as acids, how they will act? So first is a benzoic acid. I'll write. This will be acting as an acid in aqueous medium. This will dissociate as COO minus plus H plus, and there is a NO2 group. Over here, this will dissociate as COO minus and a H plus. Not complete dissociation since it is a weak acid. in aqueous medium, the complete dissociation is not going to take place. A partial dissociation is going to take place. This is H plus. Now understand, there is the intermediate. This is the negative charge which is formed on oxygen. Okay, and this is the intermediate. It is unstable. Now, when this negative charge will be stable, if it is its magnitude is decreasing. Now, one thing is that you have to remember is that negative charge of the intermediate is always stabilized by what? Stabilized by electron withdrawing group. Now this you have to know, mug up like which are electron withdrawing group. You have to by heart this electron donating group. And if there is a positive charge, if it is a positive charge, it is stabilized by electron donating group, like methyl group, or depends what effect is operating over there. So this is the NO2 group. We know that NO2 group over here shows two effects, minus I and minus M. Among this, minus M is the dominant one because always mesomeric effect or the resonance effect is the dominant. So it will be removing the electron density from this. Means it is withdrawing the electron density. This is EWG group. Means it is stabilizing this negative charge to more extent. Second, there is no electron donating or a withdrawing group. Fine. Here, in this case, there is a group which is electron donating. Means here also there are two effects. One is minus I because of the oxygen's electronegativity. Other is plus M because of the lone pair. So plus M is the dominant one. Means we will consider this to be what? Electron donating group. Electron donating group, they will destabilize the negative charge. Right? So over here there is no group in this case. So no destabilization or stabilization. But last one is destabilizing. So if you want to ask the order, if you want me to write the order, then most acidic will be what? Most acidic strength. I'll write decreasing. That is 4-nitrobenzoic acid is the most acidic. 4-nitrobenzoic acid because of the higher stability of the carboxylate or benzoic acid's ion. Then it is benzoic acid, and least will be 4-methoxy benzoic acid. Write the reagents used to bring about the following conversion. Over here, the alkyl group over here which is there, is getting converted to the carboxylic acid. Always remember, whatever may be the alkyl group, whether it is a methyl, ethyl, propyl or any hydrocarbon chain, in the presence of KMNO4, in acidic medium, it will get converted to the benzoic acid. Okay, I'll just make this clear. This is ethyl benzene over here, ethyl benzene. So where it can convert? So you have the compound this way, let's say methyl benzene. Then also if you are using KMNO4 and in the acidic medium, you will get a benzoic acid. Okay, even if it is any other ethyl benzene I have shown, if it is a propyl benzene, and you do the KMNO4, you add KMNO4 in acidic medium, still you are going to get the benzoic acid only. Now it could be this also, it could be this carbon also. There are isopropyl benzene also. There is one hydrogen on this carbon, and you add KMNO4 in the presence of acid, still you are going to get a benzoic acid. But you have to take care that if this
is the case, there is a carbon, there are methyls. In short, there is no hydrogen on this carbon. In short, there is no hydrogen on this carbon. Then you add KMNO4 and the H plus, you won't get a carboxylic acid. You won't get this. Like benzoic acid, you won't get this. Understand? So you have to take care of this. Any other means at least one hydrogen should be present on this carbon, then only you are going to get the benzoic acid.